In this video, we're going to be solving one-step addition and subtraction inequalities. So now we're going to be looking for solutions to inequalities when we have more complex algebraic inequalities. So our essential question is, how do you solve one-step addition and subtraction inequalities? Well, the answer to that is we're going to use the addition and subtraction property of inequalities just like we used the property of equalities to solve equations. We're going to use properties of inequalities to solve inequalities. So what we're going to see is we're going to solve these inequalities the exact same way that we solved equations. So if you were comfortable solving equations, then solving inequalities shouldn't be that much more difficult. So the properties that we're going to talk about here are the addition and subtraction properties of inequalities, and that says that you can add or subtract the same amount from both sides of an inequality, and the inequality will stay true. And then I just show a couple examples of that here. I start with an inequality that is obviously true. 10 is greater than 8. And then I just picked a number to add to both sides. Here I added 3 to both sides of this inequality, and I got 13 is greater than 11, which is still true. So that just shows that I can add the same thing to an inequality, and this inequality never becomes false. It is always going to be true if I add the same amount to both sides of an inequality. Same goes for subtraction. Here I subtract 2 from both sides of this inequality. I started with 4 is less than 15, and then I subtract 2 from both of those numbers, and then I get 2 is less than 13, which is still true. So this inequality remains true throughout this whole process. So we know now that we can add or subtract the same thing to or from both sides of an inequality, and it's still going to be true. So we can use it to solve problems like this. So how do you solve one-step and addition, subtraction inequalities? We're going to be undoing the addition or subtraction by using the properties of inequality. We're going to be using the opposite operation here to undo what's happening to our variable. So in this first example, I have y plus 7 is greater than or equal to 12. So I want to undo this addition. So I'm going to do that by using subtraction. So I'm going to subtract 7 from both sides of this inequality, and I know it's still going to remain true because we just proved that it was. So y plus 7 minus 7 is just y, and 12 minus 7 is 5. So my solution, y is greater than or equal to 5. So any number that is greater than or equal to 5 will make this original inequality true. And then I graph it on my number line to give you a visual of all the solutions to this inequality. So anything that is bigger than 5 or equal to 5 is going to make this true. So I could just test random numbers here to see if this works. So this is 7 right here. So 7 should make this inequality true. 7 plus 7 is 14. 14 is greater than or equal to 12, so that works. Here, if I pick like 11, 11 plus 7 is 18. 18 is greater than or equal to 12, so that works. But what if I pick a number over here that is not part of the solution on my graph? This is the number 2. 2 plus 7 is 9. 9 is not greater than or equal to 12, so that is not a solution. So that's why it's important to graph your solutions here so you can visually see all the possible solutions to this and ones that are not. And it's nice to kind of check those after you graph to see if you've graphed the right direction, just to see if you've got the right number line there. Next one, x minus 13 is less than 20. So here I want to undo the subtraction. So I do that by adding 13 to both sides. So x minus 13 plus 13 is just x, and 20 plus 13 is 33. So here's my solution. X is less than 33. Any number less than 33 is going to make this inequality true. And I show that on my number line here with that open circle. Remember, I need an open circle if it's not or equal to, and everything to the left or everything less than 33. So if I just pick a number here like 30 to test that, 30 minus 13 is 17, and 17 is less than 20. That works. And then, for example, if I were to pick a number on the other side of 33, 35 minus 13 is 22, and 22 is not less than 20, so that doesn't work. So I tested both sides of 33, and I have shaded the right way on my number line. So just some quick things to do there to make sure you get those right. So let's solve these inequalities and let's graph the solutions. G minus 2 is less than or equal to negative 8. So really what we're looking for is all the values of G that would make this true. So to do that, I'm going to have to undo this subtraction. So I'm going to be adding 2 to both sides. That's going to be less than or equal to negative 8 plus 2. And then I get G is less than or equal to, and then negative 8 plus 2 is negative 6. So G is less than or equal to negative 6. And that's my solution. And I'm going to show that on the number line here. I'm going to put negative 6 in the middle. And then again, good number lines should have numbers to the right and numbers to the left to give you that scope and scale of your number line. So everything that is less than or equal to negative 6. So negative 6 is a solution. And everything that is less than negative 6 would be to the left of it on the number line. So here is my graph. And again, just to double check, if I pick a number to the left of negative 6, like negative 7 minus 2 is negative 9. Negative 9 is less than or equal to negative 8. So that makes it true. And then if I pick one to the right, negative 4 minus 2 is negative 6, which is not less than or equal to negative 8. So that graph makes sense. Next one, h plus 8 is less than negative 13. Here I want to undo the addition, so I'm going to use subtraction. H plus 8 minus 8 is less than negative 13 minus 8. So again, subtracting 8 from both sides. These two cancel each other out. I have h is less than, and then negative 13 minus 8 is negative 21. So here's my solution. H has to be less than negative 21. Any number less than negative 21 will make this true. So again, if I graph this on my number line here, here's negative 21. Then again, I'm going to show some numbers to the right and some numbers to the left. And then it has to be less than negative 21. So negative 21 is not a solution, but it's the cutoff. So I put an open circle on negative 21, and everything that is less than negative 21, so that would be everything to the left. And there's my solution for that inequality. So solving inequalities, one-step inequalities with addition and subtraction, pretty straightforward. You can see that we're solving them exactly like we solved equations, but then that one extra step here to show these on our number line to show our solutions graphically. So here is a real-world problem that indicates an inequality. You have $143 in your savings. You need at least $360 saved in order to go on a summer field trip. Write and solve an inequality that shows how much more you need to save to go on the trip. So I have $143. That's a fact that I have. I need at least $360. So I need $360 or more in order to go on the summer field trip. So the amount of money I need to save, M, plus the $143 I already have, has to be greater than or equal to $360. So there is my inequality that shows the relationship between the amount of money I need to save and the amount of money I need. And then to solve this, I'm going to undo this addition here. So M plus 143 minus 143 is going to be greater than or equal to 360 minus 143. And I have M, the amount of money I need to save, has to be greater than or equal to 217. So that means you need to save at least $217. So if I save $217 or more, I will be able to afford to go on the summer field trip. And that is solving one-step addition and subtraction inequalities. Again, very similar to solving our equations.